Hi, I'm Jeremy Kirk with Intel 471, and this is Studio 471, our video podcast series on cybersecurity and cyber threat intelligence. Security operations centers are at the defensive core of organizations. Processing alerts quickly can give an indication if an organization is under attack, but the volume and quality of alerts vary a lot on how well the detection rules have been written. Luca Allodi is an associate professor and head of the threat analysis group at Eindhoven University of Technology, and Koen Teuwen is a PhD student there. They've co-authored a recent academic study discussing how to write lower noise rules for intrusion detection systems, and they're here to talk about it today. Thank you both very much for joining me.
Thank you,
Thanks,
Jeremy.
Jeremy.
So, your paper discusses these operational problems that happen in SOCs around the detection rules. Can you describe some of those issues?
Yeah, well, maybe Koen, I'll give a quick overview and then we can also look more in the direction of the work you're currently doing. But so our take on this is that there is, of course, a lot of automation going on in security operations centers. There is a lot of alerts, lots of events. The networks are more and more complex. But in the end of the day, there must be somebody who can make sense of what is happening. And so we're tackling it from multiple perspectives. There is a bit of on the automation and the explainability side of things. There is a particular topic in which we're investing a lot, in which Koen's work fits a lot, is that of what is the role of the analyst in this whole process. So there is the automation that fires alerts left and right and correlates event A with event B, but then what does the analyst have to do about that correlation, about these events? They need to be escalated, and why? What do you tell your customer if it's a managed SOC? So we're looking a lot into how to support the analysts in taking these decisions, those being whether analyzing the alerts or writing the rules that generate the alerts in the first place. And so lots of the work that we do around that topic looks at how support analysts in what we call alert sense making, if you want. And Koen's work fits right into that agenda.
Koen, what are the analysts saying? What are some of their, I guess, pain points?
Well, the analysts, they're very much concerned with whether they are being presented the right thing. So there's two aspects to that. One aspect is the specificity. So that means that analysts want to see security alarms that actually relate to relevant security incidents and not about irrelevant things that, such as unsuccessful attacks, for example. And secondly, they're concerned with coverage. Does my detection engine, does it raise alerts when it should? And will I be able to see the incident when it actually happens? So those are 2 points that we also investigate in the paper.
And what makes like I guess, what are some of the problems with the, I guess, post-processing tools that are used by SOCs to deal with those alerts to try to, I guess, sort out the ones that should be prioritized and the ones that are false positive or just low quality?
So for the post-processing tools, they always suffer from the low input quality, meaning that if there's already a lot of security alarms that are false positives, then it's also increasingly difficult for these post-processing tools to make sense of the data, similar to how a human analyst would suffer from that. So actually, by improving the rules that generate these security alarms in the first place, you can also benefit the post-processing tools by providing them better quality input data to make sense out of.
And so you had a couple of different entities participate in this study, and you took an in-depth look at kind of like how things were flowing through the SOC. Tell me about those entities and what did you learn from them?
Yeah, so this is a part as I mentioned before, a broader research agenda, and we started it maybe 4 or 5 years ago. And we started with, well, if we want to make security operations better, where do we start from? It's very difficult to get security data, very difficult to access security operations centers or centers of expertise that look at real data and deal with real incidents. And so we built our own. Within the Department of Mathematics and Computer Science and Eindhoven University of Technology, we built the ESH SOC, which is Eindhoven Security Hub SOC, which is a commercial entity. It's a non-for-profit. It's managed by seasoned security professionals that have been hired specifically for that. They are located on campus at the moment. Eventually, they will spin off as a foundation, but they're very closely integrated to our research and our education. In the meantime, they serve customers in the Brainport region, that is the region around Eindhoven, where ASML and other big industry high-tech players reside. And of course, lots of small, medium enterprises that can't quite afford the SOC that ASML pays for, let's say. So we established this SOC and we integrated it into our search so that we have close access to professional analysts. At the same time, we can play around with the data, integrate the technology. It's all open source. So all the stuff that we do, including the things that Koen produces or Leon or the other PhD students, they all become part of the technology pipeline that makes our SOC operate. And by doing that, we think that we're improving the technology on one side, but on the other, of course, we have this exciting opportunity to actually run a proper experiment in a SOC where you can have controls and treatments, and you can actually fiddle around with the experimental variables that for once, it can actually tell you that there is scientific backing to the fact that if you do A, then things are better, and if you do B, they're slightly less good. Yeah, which is the golden standard, let's say, of scientific proof. So we built that, and the study that Koen was mentioned was yet another collaboration with the DSH SOC.
And so you have really granular insight by setting up a SOC and getting real live data. I mean, this is like it's similar to what it would be in the real world then. Tell me about what you noted about low quality alerts that were kind of flowing through.
Well, maybe I can say a couple of words then, Koen, of course. But so in general, it's very difficult to handpick. I think it's English, yeah. The alerts that are relevant to the environments that you're measuring. Of course, lots of the alerts the rules that you find around open ET and ET open or ET pro, those kind of feeds of rules. They're all good, but they're fairly aspecific, right? They trigger on a very broad set of, well, triggers, some of which very specifically correspond to attacks, but most of which are maybe signals that something compatible with an attack may be going on. But then in a specific network, that thing is actually very common, whereas in another network, the thing is not that common. And so in the second network, it's maybe a stronger signal that something is bad, whereas in the first one, it isn't. And this is a problem of aspecificity of these rules. They're very general and not really tailored to the environments that you're looking at. And that there is a big gap between what the alerts can say and how you relate those to the assets that you're monitoring. It's very difficult to have this level of transparency where you can really say, well, this alert makes sense against this system because this system does this and does this and looks like that. And this alert matches that in these ways. And so they make sense together. I think there is a very big challenge in supporting analysts in making that connection without huge cognitive efforts for every single alert. And I think that this sort of encompasses a large class of challenges within SOC operations right now.
And that was my next question was about the trade-off between writing rules that are broad enough that maybe other people could use to detect potentially malicious behavior, but again, getting, and then also having specific ones that ensure adequate coverage too. How do you do that? How do you balance the trade-off, I guess? What do you task your analysts with, if they're going to write rules and when you're taking, perhaps external rules as well?
Yeah, so balancing specificity and coverage is indeed something that you need to do. So as part of the process that Luca described, this need for specific rules to support analysts. We did interviews with analysts to see, in their experience, which rules work well and which rules don't. Um, and out of that process came six design principles, four of which were meant to primarily increase the specificity of rules, and two of which were primarily geared towards improving the coverage. Um, and of course, we did some analysis after we found those design principles. Um, and out of that analysis, we actually concluded that there is a trade-off between specificity and coverage, meaning that if you try to make your rules more, yeah, make them cover more threats or more incidents of the same type, this will negatively affect coverage and will negatively affect specificity in some situations. Um, but we also have slightly bright news because later on in the study, we tried to apply those design principles to some rules that we consider to be very noisy to improve them. Um, and then we studied both their specificity and the coverage again. And there we found that after improving those rules, their specificity had gone up, but their coverage did not drop. So it is very much still possible to write higher quality rules. Um, but then,
Can you
of
give me,
course, there's also the other
sorry,
factor that comes into play, which is the time that you need to write rules.
can you give me an example of one of those rules where you were able to, like, just at a high level, increase the specificity as well as the coverage?
Let me see. Yeah, so there is several rules that aim at detecting exploits, for example. And as you may know, there's many scanners on the internet that continuously scan devices, and many of those scans or exploitation attempts, if they scan for vulnerabilities, these will be unsuccessful. And what many of the available open source rule sets, what they do is they focus on detecting requests. So if they see an exploit attempt, they will trigger an alert. But given the prevalence of these exploitation attempts, this is something that you as a security operations centers or an analyst shouldn't necessarily be worried about. So what we did is we shifted detection from the request to the response, and the idea being that well, we use both, but you see a request that corresponds to an exploitation attempt, and then you look at the response from the server to see if the attempt was successful or not. And this is a very, I think, good example of how you can improve rules to be more specific.
Are there what is the I guess methodology or workflow that you would recommend to ensure that some of these six principles are followed? And maybe give some examples of those six principles to keep in mind when writing detection rules.
So I think obviously the first step is when you identify an incident or another type of security threat that you want to detect, is to think about how you write a rule for this. Also taking a bit into account what you can do with, for example, if you're writing suricata rules, you need to take into mind the features that it has. Um, but that aside, you want to design a rule in a way that it adheres to the design principle to some extent. So I really suggest you of course read the paper and yeah.
Yeah, we'll definitely link to the paper in the show notes as well.
Yeah.
Do you think there's always going to be like a certain amount of sort of high level or I guess high noise alerts that should stay in place because of certain traits of activity, or do you think it is possible to significantly reduce the high noise ones, and that obviously opens up some headspace for analysts?
Yeah, definitely, that's possible. So as I said, one of the design principles that's very easy or yeah, good to apply is detecting successful attacks instead of attempts. But something else that we saw particular issues with was the usage of proxies for detection. So when you design a intrusion detection rule, you usually choose some sort of characteristic of that security threat that you can use for detection, characteristic that should be present in that threat, but not in the benign traffic that is prevalent in the environment. Um, and sometimes what we see in the open rule sets is that um, they use proxies for detection, meaning that, for example, they will detect a user agent to detect a scan or to detect some type of command and control traffic. And sometimes that works if the user agent is specifically set for a piece of malware or something like that. But sometimes malware uses a default user agent of, say, the Go library, um, which you can still detect using that proxy. But then, say you're monitoring a university network, for example, and there are students who have projects, they write some code in Go. They will also use that same user agent unless they explicitly specify they want to use a different one. And sometimes there's also benign software, like we found a VPN appliance that uses also the same default user agent. So anytime someone would open a VPN connection, this would trigger a false positive in the SOC environment because of this rule that uses a proxy. Um, and yeah, to help people write better rules, there's also a tool that we made. Well, initially we made it to evaluate the rule set to see if rules adhere to the design principle. Um, but you can also use it when writing rules. So you write a rule, you use the command line tool, and you get feedback on your rules to see what you need to improve. And this is also something very actionable that can help people write better rules, I think.
And so it automatically sort of judges, or it can go through and tell you the pointers. That's really interesting.
Yeah. And it also has another use case, actually. You can, of course, use it when writing rules, but as a security operations center, in choosing which rules to include, you can also use this tool to select the higher quality rules in favor of, uh, say, rules that don't adhere to design principles.
Yeah, and
Excellent.
and as educators, of course, we're also interested in how you integrate this into training activities, how you train new analysts in being more critical about what rules do they ingest or they apply to the system, or how do they write their own. So we're working a lot around that area with cyber ranges and training exercises to help analysts getting up to speed quickly once they join a SOC.
And Koen, the tool you mentioned, have you released it under open source license already?
Yes, it's available on GitHub. It's licensed under the European Public License. It's an open source license similar to AGPL. Um, and yeah, it will receive some more updates over time. But yeah, check it out if you want.
Excellent. As a final question, I wanted to ask about AI. There are a lot of companies developing tools for the SOC that are sort of using AI in some sort of way. There's companies doing triage with it, and others sort of combining it with automation. What do you think that this is? Do you think AI is going to impact like both rule writing itself, and then also what do you think is the general going to be impact on for SOC analysts? Like, is it going to really become, hallucinations aside, really useful in some aspects?
Yeah, most definitely, yes. I mean, just for the sheer amount of events that have to be correlated and spotted, just thinking that the human can scale up to the challenge by him or herself is unthinkable. But on the other hand, if we think that core challenge really is how you keep the human into the loop. If you outsource completely the security, the detection, the reaction, the control, the containment, all to automation, you never really know what has happened. And we've been doing some work looking into uh, up to what point even state-of-the-art detection tools that perform decently well once you look at the aggregate numbers, but then you go and you say, well, you say that this is an incident, and it really is, but why is it? And you look at the motivations that AI is peeling out. Those are, can I say, garbage, rubbish? They make no sense from an attack procedural perspective. So you say, well, an attack happened, but you don't know what happened, right? So how do you keep the human involved in that, and how the AI can actually become a way to inform the human when it's necessary, as opposed to replace their work, the work of the human, I mean, is, we think, an important open challenge for both transparency, but also for sovereignty of your own infrastructure at any level, organizational or national.
Excellent. Well, thank you both so much for joining me. I really appreciate it.
Thank you very much, Jeremy. It's been a pleasure.